Next, we will hear from Mark Leighton from Harvard Extension School, who will address forests. And in my experience, everybody seems to think they're an expert on forests, but here is an expert on forests.
Well, I feel a little bit of a duck out of water here because forests haven't played a very prominent role in this symposium so far. So I thought my connection with you all would be relating my child experience from hell in agroforestry. I grew up on a small farm in California where we had a little walnut orchard, and my parents thought it was a good idea if we had some farm animals. So we had a milk cow and a horse, and it was my brother and my role to, during the summer, go out and tether the horse and cow in this pasture land we established among the walnut orchard. And so instead of us running off with our friends playing baseball, we were on this schedule of taking water out to the cow and horse and letting them graze in an area around a stake, and then moving them every day like this, bringing them in the pasture at night. And then, of course, what happened in the fall when the walnuts fall down, instead of our other neighbors who use machinery to pick these up off the bare soil, we had to pick these up and hunt through them through the pasture grass. So it was a hellish childhood in my kind of agroforestry intercropping scheme that we established by chance. Now I can look favorably on that experience of actually doing our part to store soil carbon. So my other connection here is that as senior advisor in this program, this master's degree program that has around 400 students internationally, I can actually advise and establish new courses, and certainly one of my experiences being here is to encourage me to argue for an agricultural restoration ecology type course in our program. So we'll try to do our part. So I want to talk very briefly about forest function in carbon sequestration. There's not going to be too much science in this. But I thought what I'd focus on actually is the set of things that have gone on in forest management and conservation that I think provides a little hint of a model for how people like yourselves who want to expand the goal of restoring soil carbon in savanna, grassland, agricultural areas, might have some relevance to that goal of how you build this international coordination and political system to manage to argue for policies and to implement this. So, of course, all of us believe that natural restorative processes, ecologically given free to us, are the most cost-effective way for us to manage environmental services, including carbon sequestration. And of course, this is very true in the forestry sector. So the graph below shows our net emissions from CO2 from tropical forest and temperate forest. Notice the temperate forest is now rather temporarily below the break-even line, where temperate forests are actually sequestering more carbon than they're emitting. That is a free and short-term benefit we're getting, because mostly through places in the eastern United States, we're still having forest carbon increase both in living biomass and in dead wood on the ground and in soil carbon from the abandonment of agricultural lands. But that free benefit is going to go away in another, 50, 60, 70 years. Overwhelmingly, the problem of carbon emissions is coming from tropical deforestation, both from damaging primary forest, especially high biomass lowland rainforests, and then converting this to some other land use, either in poorly managed agriculture or tree crops like palm oil, pulp and paper, cocoa, etc. This is also the place where we have the greatest possibilities of increasing carbon sequestration in tropical forest. The future of this is very uncertain. So this is a range of models ranging from imagining that in the terrestrial or forestry sector, net carbon emissions or sinks remains more or less neutral over time, or actually emissions far outstrip sequestration, or the sequestration might actually increase and play a role as a carbon sink. And this is generally having to do with a limited set of assumptions for various kinds of scenarios. And I would say they're kind of science-dominated to some degree, and they're not very realistic when it comes into imagining how these things could be implemented in a socio-political system where these countries operate. So my background is from a long period of time doing research and then trying to influence policy in places like Indonesia. And my first foray into this nearly, 30 years ago, was heavily involved in conservation biology. And our long-term results from this place in Borneo persuaded me to get involved in very practical, applied topics. And the logic behind this was to find out the evidence that functioning ecosystems in places like the tropics, and undoubtedly true everywhere on Earth originally, rely on very large-scale mosaics of habitats for the full conservation of biodiversity. A lot of the keystone species like seed dispersal agents, a lot of the top predators as keystone predators live at low densities, require very large ranges. And these are typically much larger requirements to prevent their extinction than you typically find in protected areas now. So that realization came to me very obviously in the mid-1980s, and that changed my career to look at much more practical questions about how do you conserve habitat outside of strictly protected areas. So we kind of talk about this in terms of large land scale areas, which I think is the proper ecological unit to look at, that includes lots of diverse habitats, intact watersheds, the kinds of characteristics that mitigate climate risk, like elevational gradients that allow organisms to migrate up elevational gradients as climate regimes change, etc. So here's the problem confronted everywhere in tropical rainforest. This is the Indonesian part of Borneo. Most of Borneo is occupied by Indonesia, called Kalimantan. Here you have histograms of forest loss by elevation. So on the left there is the loss of forest in the lowland forest from 0 to 300 meters elevation. Forest loss is dominated by conversion in the lowlands. And that's, of course, because the economics of converting land to oil palm agriculture, etc., are far more beneficial in lowland areas on lower slopes, generally better soils, than they are upland. This, of course, is where all the biodiversity is at the same time. It's not up in the mountains. That's where the biological deserts are relative to lowland areas and tropical forests are. So here's a problem. Now here's a second problem. If you still look at that histogram on the left, that's the remaining forest cover in Kalimantan in 2008. The forest cover remains in the lowland. Most of this island is lowland forest originally. But notice its zonation. That little green area is the tiny bit that's protected. The red area is slated for conversion to agricultural land. That's actually available to palm oil plantation because that's categorized in Indonesia as an agricultural crop. The yellow bar corresponds to the forestry sector, which is available either for forest plantation development as a monoculture or under sustainable long-term natural forest management. So right away you look at this diagram, you realize all the action in terms of maintaining forest cover for any of its environmental service, storing carbon, biodiversity, is happening not in protected areas, it's happening in these other sectors. So we became convinced to focus our attention on the management, the long-term management of logged forests, because most forests, not only in Indonesia, most tropical forests around the world, go through a phase of becoming logged. And in general, we can see that there's very little commitment on the part of governments to put a lot of forest into protected status, and most of these will remain being zoned for productive use. So we conducted some very controversial studies, published a very controversial paper that we still stand behind solidly, which was to demonstrate that in typical selectively logged forest in Southeast Asia, but probably everywhere in the tropical world, the actual biodiversity, the conservation benefit of this forest is nearly as high as completely untacked primary forest. And that's because of the nature of logging processes under selective felling. Very few trees are actually of commercial value at any one time. Selective felling takes a low proportion of the total trees. The relative intactness of the forest is left behind. This is a logged over forest, logged through very damaging heavy industrial logging. As a trained ecologist doing this a lot, it's very hard for me oftentimes flying over such forest to tell it from primary forest. A logging road can give it away, but if there's no logging road, it's very hard to tell. And so you can see that ecosystem function of almost all kinds remain behind in selectively logged tropical forest. There's a lot of potential here to transform these as needed, for instance, where there's local communities around, to enriched forests that provide more economic plants for local people, or to increase the density of commercial species. A study was done by Putz in the mid-1990s in Sabah, northern Borneo, part of Malaysia, that demonstrated that just the imposition of reduced impact logging techniques would greatly increase the total amount of carbon being stored in these lowland forests. So these are among the, probably at the very top of the highest carbon storage forests in the world, lowland Southeast Asian dipterocarp forest. The total amount of biomass being stored is about 400 tons of dry weight per hectare. 50% of that is carbon. Under typical heavy industrialized logging, the carbon left behind is only 44% of that. You institute just very cost-effective, easy practices like directional felling, reduced log road building impacts, and you can change that figure to 67% of remaining forest cover and biomass. And so that there's a net gain there just of changing these practices of almost 90 tons of carbon per hectare. So this reduced impact logging is now the law of the land in Sabah, and the state of Sabah in Malaysia has instituted policies to try to make reduced impact logging and certified forestry the law of the land. They have made that the law of the land. Now they're trying to implement it. So what other gains do you get from these practices? You get an enormous gain in fire control from the ecological process we've already heard about. Increased forest cover changes the general microclimate of the forest floor. The possibility of that slash on the forest floor burning is greatly reduced. Less logging damage to the canopy increases the habitat value for wildlife. And also under forest management prescriptions that are ecologically based, this often leads to the designation of longer rotation times that might be in the law, which is true also in our own forestry practices. So if you take longer rotation times between logging one block, coming back through it, then that just means the overall status of the forest is improved, again, in both in wildlife quality, wild habitat quality, and in the total amount of carbon being stored. So the main point is here is these selectively logged forests in the tropics can be managed in a way where they're realizing almost the full value of their carbon storage compared to primary forests. Now here's something very controversial, but most foresters find easy to understand. You can actually increase the total amount of carbon sequestered in these forests, whether there are temperate forests or tropical forests, by logging. How do you do that? Because if the offtake of the timber is sequestered into longer-term wood products, then you actually, over a long period of time, are getting more carbon sequestered per hectare than if you strictly protect a forest, even as a primary forest. So this leads me to the rest of my talk, which is going to talk about the value of certified product labeling. So the forest stewardship certification process is about the earliest one of these, and it remains, in my mind, the gold standard for this. I could go into details during the question and answer period or talk to me later, but Principle 9 under these prescriptions is for the maintenance of high conservation value forest. So high conservation value forests, or HCV assessments, are a tool used to set aside within forest concessions areas that have important conservation values. And the important point about this is that this is spread without even expecting it to really to other sectors operating in these regions. So now the pulp and paper industry, the oil palm industry, are also following these prescriptions, including, amazingly, the Roundtable on Sustainable Palm Oil, whatever that is, nonetheless adopted a principle, 7.1, that said there should be no new establishment of plantations in high conservation value areas. Okay, so if you apply this to tropical regions, and let me tell you, the spreading horde of oil palm plantations across the tropics is going to move from Indonesia and Malaysia, where it's centered now. If you apply that to tropical forest regions, a very high percentage of areas are HCVF. The HCVF process is very powerful because it involves not only outside, generally third-party identifying of high conservation value areas, management prescriptions, and then auditing for forest owners to maintain any kind of a certified status. And here are the 6 high conservation values. The first 3 generally have to do with the conservation of biodiversity. The 4th one is critical environmental services of nature, watershed protection. Controversially, carbon storage is not yet considered as part of that. And finally, 5 and 6 have to do with providing for basic needs of local communities. So what is important about this list of so-called high conservation values is the fact that there's a natural partnership formed between those interested in social justice to those interested in environmental issues. And they collaborate in this process of enforcing companies to follow this prescription. I know I don't have much time, I think, so I just want to hustle through this a little bit. One of the controversial areas I've been working on the field and as a facilitator of solutions of this is in the peat swamp forests of Sumatra. This one little area has been generating half the total of emissions of Australia's total emissions every year, just from the deforestation and the oxidation of peat from drainage canals for pulp and paper and palm oil. So here's a quick story. AP&P, bad actor. Said in 2005 they'd follow high conservation value prescriptions. I was involved in these. They ended up failing to be able to endorse these. This is what happens under a high conservation value prescription. All those kind of checked and lined areas are designated high conservation value forests that has to be protected by the company. They're not allowed to convert that. And what Asia Pulp and Paper did in response to public criticism was to actually donate this massive area, almost 200,000 hectares, of peat swamp forest as a biosphere reserve, putting it under protected status with UNESCO. So that can be looked at as a positive development. I don't want you to focus on the environmental values provided by forests. I want you to focus on the economic values provided by forest lands. Because when you focus on this, you identify a lot of competing stakeholders, political agencies from local to national levels, local community people, local politicians, as well as the people who might derive products from these lands. Actually, setting aside lands with a industry compliant group does not necessarily solve this problem. This is an area of a concession for pulp and paper. A lot of this area was designated to be set aside. The hatched area here are land claims by local communities and politicians. So, some points for the goal of forming organizations or effective spread of this idea of restoring soil carbon. These are things I just thought about that might apply to this. Certified product branding is really effective and can simplify the message. You can just say FSC certified wood, and everybody kind of thinks, oh, this is good stuff going on. Partnering with environmental and social justice groups is really effective because politicians are sensitive to local communities' social justice issues. Focus on supply chain buyers, including financing institutions. Forget about educating everyone in the public about this. A lot of this stuff happens because corporations and financial institutions are scared to death of public criticism. They're the ones that can enforce new ways of operating in the field without having to worry too much about what percent of the American public actually believes this. The stakeholder relationships are very complicated, and they're often more important than the science. The science ends up being trivial compared with finding the institutional and the institutional stakeholder situations and policies that would make it work on the ground. But I believe you can develop these models for promoting, financing, and implementing what you want to do on a very large scale if you address these kinds of issues. Thank you very much.